Hello, in this video I'm going to be going over double displacement reactions, also known as double replacement reactions. And that's when you have two ionic compounds where the cation switches spots. So in this case, this Na and Ca are going to switch places with each other. And when doing this, this is kind of like a predict the product, where you have to predict the products and then balance both sides of the equation. So we got Na is going to pop up with Br, and Ca is going to pop up with OH. So as predicting the product, that's the first step. There's three steps usually. Second step being making sure that each molecule has an overall zero charge. And I memorized that sodium is in column 1, therefore +1 charge. Bromine is in the 7th column, or the halogen column, so it's -1. +1 -1 is 0, that's good. Calcium is in the 2nd column of the periodic table, it's 2+ charge. OH is hydroxide. I memorized it as a 1- charge, and if I didn't, I can look at my polyatomic ion sheet, which I will have, or you will have on your reactions test. -1. Crisscross it, and you should have CaOH 2. So we predicted the product, step 1. Step 2, we made sure that each product had an overall zero charge, and then step 3, we need to satisfy the law of conservation of mass, which says matter cannot be created nor destroyed. We need to add coefficients, numbers in front of these molecules, to show that we have the same number of atoms for each element on each side of this reaction arrow. Sodium is 1, 1, bromine 1, 2, we need a 2 right there. 2 bromines, 2 bromines. That means we have 2 sodiums. So we're going to have to put a 2 right there. 2 OHs, 2 OHs, and it is balanced. The last thing we need to do for this double replacement reaction is to see whether it actually occurs or not. For a double replacement reaction, our reactants are both aqueous, and then our products, we have to have one that is aqueous and one that is solid, or could be a gas. In most cases, it's going to be a solid, a precipitate, a snot-like substance. Alright, how do you do that? Well, you are going to have to use the solubility chart. So this you will have on the test. You do not have to memorize this. This should be, you should have a digital copy of this, possibly a hard copy, depending upon the year. And, alright, what are we looking at here? NaBr. So, NaBr, this is the anion, so Br, the negative charged one, it's right here, bromide, and it's going to be aqueous in most cations, but we're talking about Na. If Na was in this column right here, it would be a solid, but Na is not, so therefore it falls under most cations, and we're talking about aqueous. NaBr is aqueous. Next, hydroxides. So looking at hydroxides, where are they? They're over here. We're talking about calcium hydroxide. Cations of columns 1 and 2, calcium is in column 1 and 2, are aqueous. So, we've got aqueous right here. Both of our products are aqueous. If both products are aqueous, then will this reaction occur? The answer is no. It will be no reaction. Alright, let's do one more. Let's do PbNO3 plus HCl. So remember, first step, zoom in on this, is predict the products. So this Pb and H are going to switch spots. We're going to be with PbCl plus H NO3 in this case. Alright, and Pb, well, this is a -1, Pb would have to be a +2 because there's 2 of them. So therefore, Pb is a +2 on this side, chlorine's a minus, crisscross it, and it's 2. So essentially what I did here was step 1, predict the product, just switching them, switching the cations. Step 2 is now we need to make sure that the overall charge is 0. So nitrate's minus, hydrogen plus, that one's balanced. And then step 3 is add coefficients to make sure it's balanced on both sides of the arrow. 2 nitrates, 1 nitrate. So I'm going to need a 2 right there. 2 hydrogens, 1 hydrogen, need a 2 right there. 2 chlorines, 2 chlorines, 1 lead, and it's balanced. Make sure we add these states, aqueous for our 2 reactants, but now we need to double check our solubility chart to see if our 2 products are both aqueous, or maybe one is aqueous, one is solid, in which the reaction would then occur. PbCl2. Alright, so chlorine is right over here. Ooh, Pb is right here under the solid section. So this PbCl2 definitely is a solid. And HNO3 nitrates, these guys are always soluble, they're never precipitate, so that's going to be aqueous. Alright, so we have one solid, one aqueous. Will this reaction occur? The answer is absolutely yes. It will occur. And that is double replacement reactions using the solubility chart.